Imagine a world where the ground beneath your feet could power your entire city. Sounds like science fiction, right? Well, it's not. This hidden powerhouse is called geothermal energy, and it's revolutionizing how we think about clean power. Welcome to the Clean Energy Journey YouTube channel, where science meets sustainability. We share how green energy will save our planet in the future. Geothermal energy is often called a hidden powerhouse because it comes from beneath our feet, yet many people know little about it. In the midst of today's climate crisis and energy shortages, it stands out as a reliable, renewable source of power. Unlike solar and wind, which can be intermittent, geothermal can provide constant baseload electricity 24/7. This makes it a crucial player in the transition away from fossil fuels. To understand geothermal's unique role, let's compare it with other renewables. Solar energy is abundant, but only available during daylight and is weather dependent. Wind power can be strong in some regions, but is unpredictable. Hydroelectric power is reliable, but limited by geography and environmental concerns. Geothermal, on the other hand, is stable, clean, and capable of working in any weather condition. At the heart of geothermal energy lies the concept of the geothermal gradient, the rate at which temperature increases with depth inside the Earth. On average, the temperature rises about Y-30 degrees Celsius per kilometer. This underground heat comes from two main sources: radioactive decay of elements like uranium, thorium, and potassium, and residual heat left over from Earth's formation billions of years ago. Sometimes, this heat escapes naturally to the surface through hot springs, geysers, and volcanic activity. These natural phenomena are direct evidence of the immense thermal energy stored beneath us, waiting to be harnessed for our benefit. So, how do we tap into this underground powerhouse? The principle is simple. We access underground reservoirs of hot water or steam, bring it to the surface, and use it to generate electricity or provide heating. There are three main types of geothermal power plants. Dry steam plants use steam directly from underground to turn turbines. Flash steam plants pump hot water under high pressure, then release the pressure to create steam for turbines. Binary cycle plants use moderate temperature water to heat a secondary fluid with a lower boiling point, which vaporizes and drives turbines. But geothermal energy isn't just about electricity. It has direct use applications too. District heating systems can warm entire cities. Greenhouses use geothermal heat to grow crops year-round, and industries harness it for drying and processing materials. The versatility of geothermal energy is truly remarkable. Let's take a global tour to see geothermal in action. In Iceland, nearly 90% of homes are heated with geothermal energy, making the country a global leader. Their volcanic activity provides easy access to underground heat. In the United States, the Geysers Field in California is the world's largest geothermal power complex, producing enough electricity for hundreds of thousands of homes. Kenya, located in the Rift Valley, has rapidly expanded its geothermal capacity, now providing a significant share of the nation's electricity. But the potential doesn't stop there. Countries like Australia, the UK, and Canada have untapped geothermal resources that could be developed with new technologies such as enhanced geothermal systems, EGS. The future of geothermal energy is bright and expanding beyond traditional volcanic regions. Now, let's talk about the environmental benefits of geothermal energy. It's clean, with emissions far lower than fossil fuels. It's renewable and sustainable, with reservoirs lasting decades if managed properly. And it provides reliable baseload energy, unlike intermittent renewables. These advantages make geothermal a powerful tool in our fight against climate change. However, like any energy source, geothermal does come with some challenges. Land use is a concern, as geothermal plants require drilling and infrastructure, which can impact ecosystems. In rare cases, injecting water underground can trigger small earthquakes, a phenomenon known as induced seismicity. Some systems also require large amounts of water, raising concerns in arid regions. But it's important to note that these challenges are relatively small compared to the risks of continued fossil fuel dependence, and they can be managed with careful planning and technology. Speaking of technology, the future of geothermal lies in innovation. Enhanced geothermal systems. EGS use hydraulic stimulation to create artificial reservoirs where natural ones don't exist, expanding geothermal's reach beyond volcanic zones. We're also seeing exciting developments in integrating geothermal with other renewables. Geothermal can balance solar and wind by providing steady baseload power, while renewables handle peaks. There's even potential for geothermal energy to power electrolysis, producing green hydrogen for clean fuel. Looking forward, geothermal could expand far beyond volcanic regions thanks to EGS and advanced drilling technologies. Governments in the US, EU, and Australia are investing heavily in research and subsidies to accelerate deployment. Developing countries in Africa and Asia are also turning to geothermal to secure stable, low-cost energy. This global interest is no surprise, as geothermal fits perfectly into global decarbonization strategies, complementing solar, wind, and hydro in achieving carbon neutrality by mid-century. Geothermal energy combines ancient natural heat with modern technology to provide one of the cleanest, most reliable forms of power available today. It's often overshadowed by solar and wind, but its importance is growing as the world seeks energy solutions that are both sustainable and dependable. So, what can you do to support this incredible energy source? Start by supporting clean energy policies in your area. Explore geothermal solutions in your region. You might be surprised at what's available. And most importantly, stay curious about how science can transform our energy future. We'd love to hear your thoughts and questions, so drop them in the comments below. And don't forget to subscribe to continue learning about renewable energy and sustainability. Together, we can harness the power beneath our feet and create a cleaner, brighter future for all.